Okay, we're going to look at simplifying rational expressions today. And as we do this, one thing to make sure we understand is that we cannot cancel things when you have addition and subtraction. And so we're going to have these expressions that are pretty complicated, like this. And so you're going to see it's getting pretty complicated. Now the temptation is to want to say, oh, 2x squared and 2x squared. I'm going to cancel those out. But we can't fall for that trap. That's not a valid way of simplifying. And so just like if you have 5 plus 8 over 5 plus 3. As I look at that, 5 plus 8, that's going to be 13. 5 plus 3 is 8. So I should get 13 eighths. But if I cancel these out, I get 8 thirds. Now 13 eighths and 8 thirds are two totally different things there. And so that's not a valid method of simplifying because you don't get the same thing if you cancel them out or if you don't cancel them out. And so we got to make sure that we are conscious of that. You cannot simplify when it's using addition and subtraction. And so here, I cannot simplify anything here. Now, one thing we do want to look at anytime we're doing this is if they all have something in common. And so here, 2x squared plus 18x plus 40, they all have a 2 in common. So I want to pull out a 2. And when I pull out a 2, I just get x squared plus 9x plus 20. That's all over. Now I look here, 2, 7, and 15. There's nothing I can pull out there. So I have 2x squared plus 7x minus 15. Now, as I try to simplify this then, this now is multiplication here, so I have a chance to possibly simplify. But again, I can't simplify here because this is part of an addition and subtraction part. And so I need to go and look at how I can somehow get to a point where I can simplify this. And the method for doing that is by factoring. Because when you factor, what you're doing is you're creating a multiplication problem. And so when I factor this out, I see that I have positive 20 here. The only way to get x squared is x times x. I need to multiply two numbers together to get 20. That when I add them, I get 9. That's 5 and 4. I want it to be a plus 9, so it's going to be plus and plus. Now, as I do my denominator here, the only way to get 2x squared is to take 2x times x. To get 15, I want to try to multiply two numbers together to get 15, and when I subtract the outside and inside terms, I need to get 7. So I could try 3 here. 2 times 3 would be 6, though. 6 minus something, that's going to be smaller than 7, so that's not going to work. So I try 5 because 5 is a little bit bigger, but not so big to go to 15 there. 2 times 5 is 10. 10 minus 3 is 7. Okay, that's the one I want. I want it to be a positive 7x, so I got to go plus 5. So I have positive 10x minus 3x. That gives me the positive 7x, but the minus 15 at the end. What you'll see here is on the top here, I'm taking everything here and I'm multiplying. So now I have a multiplication problem. Now when it is multiplying, then you can simplify when you have the same thing. So I'm multiplying the top times x plus 5, I'm multiplying the bottom by x plus 5. Therefore, those two things will cancel out. And so what I'm left with is 2 times x plus 4 over 2x minus 3. Again, I cannot cancel here because the 2x minus 3 is all together there. If I could pull out a 2 from here, then I could cancel because it'd be with multiplication. Now the other thing that goes along with these problems is we want to know if we can put all values of x into this problem and be okay. Here we cannot, because one thing that we cannot do is we cannot divide by 0. And so what I'm concerned about is at some point this would equal 0. And so I'm looking at when would 2x minus 3 equal 0. I don't care about this top part. What I care about is dividing by 0, because in math you cannot divide by 0. Well, 2x minus 3 equals 0. If I add 3 to both sides, it's going to equal 0 when x is equal to 3 halves. So this is considered to be undefined at x equals 3 halves. So if it asks you for where it's undefined, what you're looking at is, are there any x values that would cause the denominator to be 0? Because if there are, this expression will be undefined at that x value. Now that could be a bunch of numbers, it could be just one number, like in this case. Let's look at one more. Now that you've seen that first example, let's glance at one more. Let's just do a little bit of a quicker one. I have 5x over x squared plus 3x. Again, as it is written now, I cannot simplify anything. This is an addition problem right here. I cannot do anything. But look at what they have in common here. Both of them have an x, and so I can pull that x out to the front. X, I take away an x from x squared, and I just have x. I take away an x from the 3x, and I have x plus 3. Now I'm taking the 5 times x, and I'm taking the x plus 3 times x. Since they're both being multiplied by x, those simplify out. Those cancel out to be 1. And so all I'm left with is 5 over x plus 3. Again, if I want to know when it is undefined, it's undefined when I divide by 0. This one will be undefined then at x equals negative 3. I got that because I was looking at when x plus 3 equals 0. Well, x plus 3 equals 0 at x equals negative 3. So that is where it's undefined. Not all expressions have a point where it's undefined. If I went through and simplified and I got something like x plus 7 over 5, this is an expression. I can't simplify it any farther, and there's no value for x that will ever make this undefined. And so sometimes all numbers are going to work. Sometimes there are no values where x is undefined, and that's okay to have that as well. So really on these problems, what you're looking to do is factor it, create a multiplication problem. Once you have a situation where you're multiplying, if you have the same thing in the numerator as you have in the denominator, you can simplify those out to be 1, therefore canceling out. Guys, and to end the day here, you may have noticed people are getting bigger and bigger all the time. And so we have these people that are, great basketball players, but even the biggest basketball players who are over 7 feet tall and just huge people, their noses are never 12 inches long. Why is it that a person's nose cannot be 12 inches long? Well, I'll tell you. Because if a nose was 12 inches long, it would be a foot.